Assalamualaikum warahmatullahi wabarakatuh. Okay, let us continue about our discussion on chapter 2 kinematics. Now we are in part 3, that is equations of linear motion. Okay, so for linear motion we will touch on one specific type of motion, that is motion with constant acceleration. Okay, so please take note that linear motion is motion in one direction. Okay, so this motion, this linear motion with constant acceleration has two characteristics. Okay, so the first one is the rate of change of velocity in time duration is constant. Okay, and number two, the average and the instantaneous acceleration is equal. Okay, so for linear motion with constant acceleration, there are 5 equations that are normally used to solve problems of this motion. As we have discussed before, okay, we will use parameters of linear motion, that is the initial velocity u, the final velocity v, the linear acceleration a, the displacement of the object s, and the duration of motion t. So all these 5 equations can be used to solve any problem on linear motion with constant acceleration. Let us look at the example 4. An object starts from rest and moves with constant acceleration of 8 meters per second square along a straight line. Compute A, the speed at the end of 5 seconds, and B, the distance traveled in 5 seconds interval. Okay, from the questions, let us identify what are the informations given. Okay, the first one is the direction of motion. Even though in the equation it does not explicitly discuss what is the direction, we can safely assume that the direction of motion to be in the positive x direction, and the starting point is at position x not equal to 0 meters. And also from the equation, we are also given the information on the initial velocity, which is v naught or u, which is equal 0 meter per second. Okay, and we got this from the statement of the object starts from rest in the equation. So rest here means the object starts with 0 meter per second. Secondly, we have the information of 8 meter per second square, that is A. And thirdly, we have the duration of motion, that is 5 seconds. So looking at the information given, so the most obvious choice of equation is v equal to u plus at. So by substituting all the informations that we have, we can calculate v, which is the final velocity of the object at t equal to 5 seconds. B, the distance traveled in the 5 seconds interval. The distance here means the displacement. Okay, so based on the informations that we have, okay, so we already have u, we already have a and t. So to calculate s, one of the equations that we can use is s equal to ut plus half at squared. Okay, and by substituting all the values that we have, we can determine that the object's displacement at t equal to 5 seconds is 100 meters. Okay, now we discuss example 5. Okay. Example 5 says that the spotting a police car, you slow down your car from 75 km per hour to 45 km per hour over 88 meters. A. What is the acceleration assumed to be constant? And if you continue to slow down the car with the acceleration calculated in A until the car stops, what distance will be covered? Okay. So we start by identifying the information given in the equation. Firstly, 75 km per hour here is the initial velocity. 45 kilometers per hour here is the final velocity over a displacement of 88 meters. From A, we want to know about the acceleration. Okay, so the best equation here is v square equal to u square plus 2as here. Okay, so substituting the values in the equation, we can calculate A to be minus 2.05 times 10 to the power of 4 km per hour square. Okay, and if the car continue with the acceleration as calculated in A until it stops, what is its displacement? This is for B. Okay, and again, the equations most suitable is v square equal to u square plus 2as. This is because we do not have any information on the duration of the motion. Okay, so we cannot select the other 4 equations that requires the information of t here. Okay, so for B now, there is a slight change in the parameter. Okay, whereas U is still 75, but now V is not 45. V is now 0 because until the car stops. Stops here means V equal to 0. And using the new values obtained from the question, okay, we substitute into the equation to get S to be 0.137 kilometers. Okay, that's all for equations of linear motion. Thank you for your attention. See you in our next video. We will discuss motion under the influence of gravity.